Hey guys, welcome back to Math with Ms. B. So we're going to talk about finding inverses, okay? And in order to do that, we're first going to look at what functions make inverses, okay? The very specific ones are one-to-ones, all right? If you have a one-to-one function, that means you have one x for your y's and you have one y's for your x, okay? You'll never repeat the same value in either your x values or your y values, okay? So another way to look at this is if you have, let's say we have a parabola, okay? We know that a parabola is a function because it passes the vertical line test. So we know that it's a function. But in order to be a one-to-one function, it also has to pass the horizontal line test, which in this case, a parabola does not because we would hit the graph twice. Okay, so one-to-one will pass the vertical line test and the horizontal line test. Okay, so if you're given a picture, you can determine that. If you are looking for the inverse algebraically, though, we have a couple of steps. All right, so in order to find the inverse algebraically, these are the steps you want to find. Okay, the first one is we're going to switch the x and the y. Remember that y can be written as f of x. That's just a fancy way of writing y, okay? So we're going to switch places with our x and our y. Then we're going to solve for the new y value. Wherever the y value is, we're going to solve for that one, okay? Remember, that means you are going to isolate, in this case, the y. And then the last thing is we're going to check our domain. We're going to make sure that our domain doesn't change at all, okay? So I have 3 examples for you, a mild, easy, medium, and then a spicy one. Okay, so let's go for this. So zoom in here. The first thing that I'm going to look at is, here's my function. I'm going to do step 1, switch my x and my y. Remember, this is a fancy way of saying y, and that's just an x, right? So I'm going to switch places with those. So I'm going to write x over here, switching place, equals 2, my x is going to become my y. So they swapped places, plus 3. So that's kind of like my step 1. I switched my x and my y. All right. Step 2, I'm going to solve for my y. I'm going to isolate this guy all by itself. Okay. So I am going to draw my line down. Take your time. Don't skip steps. I'm going to subtract 3 from both sides. So 3 minus 3 is 0. That's what we mean when we say cancel. So if you want to write that step, it'd be 2y plus 0. 2y plus 0 is 2y equals x minus 3, because I can't combine those. Those aren't like terms. Okay. Next up, what I'm going to do is I'm going to divide both sides by the 2. Divide by 2, divide by 2. 2 divided by 2 is 1. So remember, that's like saying 1 times y. 1 times y is y equals, and there's nothing we can simplify, so we get to be lazy and leave it like that. Okay? This is our inverse. So the only thing we're going to do is we're going to write it in the correct form. An inverse function is written as f to the negative 1 of x. So f of x is our original function. F to the negative 1 of x is our inverse function. So our final answer is going to look like this. X to the negative 1 of x equals x minus 3 over 2. That's our ending answer. Okay. We don't have a variable in the denominator here. We don't have any crazy exponents, so the domain will not need to change. Okay, so that's an easy one. Again, step 1, we switch the x and the y. step 2 was all of this where we solved for y. All right, let's take a look at a slightly more complicated one. Okay, more complicated just means you might have to do more than just adding, subtracting, multiplying, dividing. Okay, so our original function, f of x is equal to x squared plus 9. So our first step, we're going to switch the x and the y. So I'm going to write, instead of f of x, I'm going to write x equals x squared. Instead of that, I'm going to write y squared plus 9. Switched my x and my y. Now I'm going to solve for y. Draw my line down the middle. I'm going to subtract 9 from both sides. 9 minus 9 is 0. And I'm left with y squared equals x minus 9. Can't combine like terms. Okay. Last but not least, I am going to take the square root of both sides because I need to get rid of the squared. And I would be left with y equals the square root of x minus 9. Again, we can't break that apart because of the x minus 9. Okay? So to write it in the correct format, we're going to write f to the negative 1 of x equals the square root of x minus 9. Okay? Here's where we want to take a step back and make sure this guy for the domain, does anything need to change? Yes, it does. Because remember, we cannot take the square root of a negative number. So what we're going to do is we're going to change, I'm doing shorthand here, we're going to change our domain. If you don't remember how to do domain, when you're doing a radical, you have to set what's underneath the radical greater than or equal to 0. We cannot take the square root of a negative number. So I'm going to subtract 9 from both sides. Sorry, I'm going to add 9 to both sides. Pay attention. Negative 9 plus 9, 0. So x has to be greater than or equal to 9. This is our new domain. This is that step 3 that we need to do occasionally, not always. So this is step 2, solving for y. This would be our step 3 where we're checking the domain if there's anything we need to adjust for. Okay? If there's ever questions, remember in the comments, send me a message. That way we can work through them. We're going to do one more. We're going to do a slightly spicier one. All right. Notice that this has a variable in the numerator and in the denominator. So we need to just be careful with that. Okay. So I'm going to do step 1 where I switch my x and my y. So this is my x equals, and then I'm going to have 3, and instead of an x, I'm going to write a y over y plus 2. So I switched my x's and my y's. And now what I'm going to do is solve for my y. Taking things slow. The first thing I'm going to do, draw my line down the middle. This is a fraction. We don't like dealing with fractions, so I'm going to make it go away. The only way you make a fraction go away is by multiplying by the denominator. So I'm going to multiply the whole denominator, y plus 2. So I'm going to multiply the right side by y plus 2. And I'm going to multiply the left side by y plus 2. Because whatever you do to one side, you have to do to the other. On the left-hand side, remember, I'm going to distribute. So I'm going to distribute x to the y. And I'm going to get xy, and I'm going to distribute the x to the 2. Again, you're multiplying, so this would be plus 2x equals y plus 2, those would cancel out, and I'll be left with 3y. Y plus 2 divided by y plus 2 is 1. Anything over itself is 1. That's why they cancel. Okay. Now remember, ultimate goal, I'm solving for y. So I'm going to move all of my y's over to one side. So I'm going to subtract xy over here, subtract xy over here. So xy minus xy, 0, cancels out. I'm left with 2x equals 3y minus xy. Okay, I have two y's here. I need to get them together, but I can't get them together with the 3 and the x. So what I'm going to do is factor out the y. So if I factor out a y, that means I'm going to divide this guy by y and this guy by y. Y divided by y is 1, so I'm left with 3 minus y divided by y is 1, x. So I've factored out this y so that I can solve for it. Equals, I still have my 2x. Now I'm going to get rid of 3 minus x on this side and 3 minus x on this side. Cancels. Y equals 2x divided by 3 minus x. So there's a lot more algebra involved in this one. That's why it's a spicy one. It's all possible. Take your time. Again, we're doing all the same rules we usually do. When we don't like fractions, we get rid of them by multiplying by the denominator. And then we're doing some distribution and some factoring. Okay. For my final answer, I'm going to have f inverse of x equals the 2x over 3 minus x. For the domain, again, I have a variable in the denominator, so we need to account for that with our domain. So I'm going to write 3 minus x equals 0. Because we can be positive, we can be negative, we cannot have a 0 in the denominator or our function goes undefined. Solve for the x, just like we've been doing. 3 minus 3. I have negative x equals 0 minus 3 is negative 3. I can't have negative x, so you can divide both sides by negative 1 if you want. You can multiply both sides by negative 1. It's up to you. But this would give me x equals a positive 3. So as long as your x is not 3, right, because 3 minus 3 is 0, your function can be anything else. You're just setting up that domain, okay? Let me know where you guys have questions. I'll talk to you in class and we will go over more stuff. All right, see you guys next time.